You settle into the quiet, letting the night unfold around you, as if it understands what you came here for. The stillness has a way of softening your thoughts, slowing them into something gentle, something almost curious. There's a calm glow drifting in the back of your mind, the kind that appears when the world finally stops asking anything of you. If these quiet journeys feel like a place you belong, you may let your hand rest lightly on the like button. Subscribe if the softness here feels right, and let the small bell stay close so another peaceful night can find you again. The calm deepens, and in that silence, a single question rises like a faint shimmer in the dark. What if something out there has been watching us with the same quiet curiosity you feel now? The thought lingers weightless, leading you into a story that begins far beyond the edge of Earth. The calm stays with you for a while, almost as if the room understands that your mind is ready for something gentle, something curious. You feel the quiet settling deeper, the way soft sand settles under a slow tide. Your thoughts float without weight, circling around that faint shimmer the night placed in your hands a moment ago, the idea that something out there might be looking back. It's a strange comfort, isn't it? The possibility that curiosity isn't a one-way street, that the same instinct pulling you toward the sky might exist on worlds older than our sun. You breathe in, letting the air cool your chest. The silence feels wider, like a space that's been waiting for you to notice it. Somewhere beyond that quiet, the earth hums. Not loud, not sharp, more like a deep, slow vibration that holds everything you've ever known. NASA's magnetometers pick up that hum every moment, reading the invisible currents wrapping around the planet like a soft shield. A shield strong enough to protect your pulse from storms exploding 93 million miles away. You probably never think about that shield when you're walking outside or scrolling through your phone. Most people don't. But satellites hear it all the time. They move through that magnetic ocean as if drifting through a gentle heartbeat. Imagine floating there with them for a moment, in that thin electric silence above the clouds, watching the earth glow with ribbons of oxygen and nitrogen. The auroras shimmer like thoughts that slipped out of the planet's dreaming mind. Scientists describe them as collisions between solar particles and atmospheric gases, but when you look at them long enough, they almost feel emotional, like the sky remembering something softly. You stay with that image for a breath, letting it spread through you. It's easy to forget how vast the space above you really is. NASA's Swarm mission once published a figure 250 miles above Earth. A number so simple it barely registers, yet the emptiness at that height could swallow cities without effort. Up there, everything feels fragile. Even sunlight becomes a thin blade. Radiation hums like static. Your body, if unprotected, would last only minutes, not because of dramatic explosions or cinematic catastrophes, but because the quiet would drain the heat from you faster than you could replace it. Space is silent, but its silence is not gentle. You sense the contrast between the calm inside your room and the cold above the atmosphere. It makes the quiet feel even safer. You feel the night shift slightly, like a curtain pulled back, just enough for a new thought to enter. Not sudden, more like a small gravity well forming in your mind. A pull towards something far beyond our shield, far beyond even the familiar planets circling the sun. You let that pull guide you. Somewhere between the orbit of Jupiter and the dark beyond Neptune, the solar system becomes a different place. A place where sunlight fades until it's weaker than a dying candle. Where heat is a memory. Where objects drift in patterns older than human history. Astronomers sometimes call this region the quiet outskirts. A fitting name because out there, everything slows. Temperature drops, motion softens, light arrives late, and in that chilled, endless silence, something unusual passed through our neighborhood. You may have heard whispers of Oumuamua years ago, the first known visitor from interstellar space. A shape that accelerated in ways natural objects rarely do. Harvard's Avi Loeb described it as unlike anything we've seen, and he wasn't exaggerating. The numbers didn't behave. The reflection didn't behave. Even the trajectory felt intentional. But the story didn't end with that first visitor. Another one arrived, quieter, colder, more fragmented. An object cataloged under a name that seems too technical to hold such mystery, 3IATLAS. You let the name settle in your mind. It feels like an incomplete sentence, as if it's waiting for you to ask the rest. When astronomers first detected it, the light curve caught their attention. Brightness rising, fading, rising again like a signal flickering through static. Natural objects do that sometimes, but this one fractured in a way that felt different. It broke apart gently, not like a comet unraveling in heat, but like something built from thin reflective layers separating into pieces. Pieces that kept their brightness longer than expected. Pieces that moved as if they remembered each other. Scientists logged the fragments. They called them mini-objects, a term that sounds harmless, almost cute, until you realize that each one drifted with a faint push. No gravitational model predicted. A push so subtle it could be missed if you blinked. You let your breath out slowly. The idea lingers. What kind of object falls apart like that? What kind of structure leaves behind fragments that stay bright, steady, and strangely coordinated? There is a moment where your own curiosity sharpens. Not tense, not alarming, just a quiet edge forming under your thoughts. Some researchers suggested pressure from sunlight. Some pointed to gas venting. Others admitted the data didn't fit comfortably anywhere. You might wonder if you held one of those fragments. What would it feel like, cold light as a leaf? Sharp, like thin metal? Or smoother, more alien, like a material shaped by hands that never lived on Earth? The question feels too delicate to answer, so you let it hang in the air. NASA's reports on 3IATLAS don't deny the anomalies. They simply describe them in the careful tone scientists use when something refuses to fit inside their models. Words like unexpected non-gravitational acceleration, anomalous brightness, stability. Phrases that sound calm but carry the weight of deeper questions under their surface. You sense those questions moving through you, settling wherever your curiosity feels most alive. The night seems to lean closer, waiting with you. It becomes almost comforting to imagine that somewhere far from the warmth of the sun, a fragment of something engineered, or at least something unfamiliar, drifted silently into our system. Not visiting, not invading, just passing through. A traveler with no need for introductions. You picture it gliding through the quiet outskirts, carrying whatever story shaped it. A story that might have begun on a world where light has a different color, or where intelligence grows in forms we wouldn't recognize. The thought isn't frightening. It feels strangely gentle, like a truth spoken softly. You breathe again, noticing how calm your body feels, how your mind has slipped deeper into this quiet exploration. And as your attention settles on that drifting fragment once more, a slow realization forms that the mysteries surrounding 3IATLAS aren't only in the cold void of space, but in the way your own curiosity responds to them. The night holds that realization carefully, letting it stay warm, letting it unfold at its own pace. Somewhere in that unfolding, your mind begins to sense a faint thread leading forward, not a sharp turn, not a shift, just a continuation of the same wondering you're already in. A wondering that will carry you deeper into the story of the fragment, its behavior, and the possibilities it suggests as it moves through the dark. The quiet stays with you, almost as if the night wants to make sure you're steady before showing you what comes next. Your breath finds a calm rhythm matching the soft pulse of curiosity in your chest. You feel something in you lean forward, not physically, but in that quiet way the mind reaches when it senses a mystery inviting itself in. The image of 3IATLAS lingers, a fractured object drifting through the dark, and you sense there is more beneath the surface of those fragments than the early reports dared to say. Far from our warm blue world, the solar wind thins until it feels more like a sigh than a force. Yet even there, instruments from NASA's deep space monitoring stations captured traces of something unusual, not loud, not showy, just a pattern that didn't match the expected drop in motion. You might imagine it as a tiny shiver in the data, a deviation so faint you'd miss it unless you were staring directly at the graph. But scientists did stare, for days, for weeks. One of them described the curve as persistently off a phrase that sounds harmless until you realize it means every model they tried failed to make the numbers behave. You breathe slowly, letting that idea settle. Natural objects rarely argue with physics. When comets tumble, their brightness follows predictable patterns. When chunks of ice sublimate in sunlight, the expelled gas pushes them in measurable ways. When debris drifts, it drifts without preference. But 3IATLAS behaved like it had preferences. Some fragments glided in lines that suggested a shared memory, as though each piece still understood the orientation of the original structure. It's a strange thing to consider fragments remembering. Yet the motion looked almost thoughtful, like pages of a book trying not to scatter in the wind. You feel the room soften as your mind holds on to that image. NASA's early observational logs noted a gentle acceleration at distances where sunlight should have been too weak to create it. A senior researcher described it as a pressure without a source, a poetic way of admitting that nothing in their equations produced the same signature. You let the phrase echo in you, a pressure without a source. It feels like a whisper from something that doesn't need to be loud to be heard. You picture the fragments drifting through the deep blue of interstellar space before entering our system. Out there between the stars, radiation ages materials in ways we wouldn't expect. Cosmic rays carve microscopic patterns into surfaces until even metal begins to look ancient. If 3IATLAS had been traveling for millions of years or billions, its appearance would carry the fatigue of time itself. There's a strange comfort in imagining that kind of age. A comfort born from the idea that the universe keeps stories so old we can barely hold them. Your thoughts drift toward shape. Scientists never agreed on what the original body looked like before it fractured. Some suggested a thin sail-like structure, similar to Oumuamua's hypothetical profile. Others proposed a layered composition, multiple panels bonded together, each one thin enough to reflect sunlight with unusual efficiency. You imagine holding one of those panels, cold, smooth, so impossibly light you'd wonder if it was real. Its edges would carry the erosion of cosmic weathering, the faint scars of places it passed through where radiation was strong enough to alter atomic bonds. It's hard not to think of such a structure as engineered, but you feel the need to stay anchored in the gentle honesty of science. Not jumping to conclusions, just sitting with possibility. Harvard's Avi Loeb once said, "When something doesn't behave like nature, we should be open to the idea that it might not be natural." You hear that line drift through your memory, soft, measured, cautious. A scientist's way of opening a door without stepping through it too quickly. You let the door stay half open. Far across the outer reaches of the solar system, sunlight becomes so thin it almost forgets itself. At those distances, the faintest glow from an object means it's reflecting more than expected. 3IATLAS's fragments kept their shimmer longer than ice or dust ever should. Some astronomers describe the brightness as unreasonably persistent, the kind of phrase that makes you pause. You imagine the fragments catching light like tiny mirrors, each one flashing a small signal into the dark as it rotated. If someone were out there watching, those flashes might look like a heartbeat, You wonder what a civilization older than ours would consider normal building material. Would their craft look like metal to us? Or something lighter, woven from mineral filaments or nanostructures? Materials that could last a journey across interstellar space without crumbling. Your mind follows the thought gently, like drifting along a slow current. NASA's stereoscopic imaging revealed that one piece of 3IATLAS changed orientation in a way that suggested a momentary correction. Not sharp, not mechanical, just deliberate enough to make researchers hesitate before committing the observation to writing. You might feel a small thrill at that, a quiet, private spark of wonder. The kind of spark that doesn't shout, but hums softly in the back of your mind. You sit with it, letting the sensation spread through you. It's fascinating how your body relaxes even while your curiosity sharpens. A paradox that seems to define the entire experience of exploring interstellar mysteries. You aren't rushing anywhere. You're simply letting the unknown unfold at its own slow rhythm. Some scientists propose that the fragments could be remnants of a much larger craft, something that once relied on light pressure for propulsion. A concept we're only beginning to test on Earth. The idea of a light sail isn't science fiction anymore. Experiments from NASA and the Planetary Society prove that sails thinner than a fingernail can ride sunlight across space. Now imagine building one not for thousands of miles, but for light years. Your breath deepens with that thought. The scale becomes almost overwhelming, yet the softness of the night keeps it manageable. There's no rush to understand, only a gentle invitation to keep wondering. 3IATLAS moves again in your imagination. A ghost of a structure, drifting through cold silence, carrying a history you'll never fully see. A history written in faint scratches, in thermal scars, in the subtle way each fragment responds to the emptiness around it. You feel the edges of your awareness soften as you picture the long journey those pieces survived. Collisions with tiny dust grains at cosmic velocities, the slow abrasion of radiation, the gravitational pull of countless stars it passed. So many forces shaping it, so many stories hidden in those forces, and still it reached us. You let that idea settle inside you like a small ember, a quiet heat, a reminder that the universe nudges strange things into our path when we least expect it. Somewhere in the gentle calm of your mind, another question begins to form, so soft you barely notice it shaping itself. It feels like the beginning of a deeper curiosity, one that will guide you into the heart of the mystery behind those fragments, the intentions they hint at, and the possibility that they were never meant to travel alone. The image of those drifting fragments follows you gently, as if each piece carries its own quiet presence. You feel the night holding you in a soft embrace, giving your thoughts room to roam while staying grounded in the stillness around you. There's something soothing about imagining an object older than your entire species, moving silently through space, carrying patterns etched by light and darkness across unimaginable distances. Your breath settles as you trace that journey in your mind. NASA once described interstellar travel as a slow archive of the cosmos, a poetic phrase buried inside a technical report, yet it feels fitting here. Because as you picture those fragments gliding between stars, you begin to sense they may not only be debris, they might be memories. Not memories in the human sense, not thoughts or emotions, but memory written in structure. Memory shaped by where an object has been, what forces shaped it, what collisions left their mark. You let that idea linger. If a fragment travels through the interstellar medium for millions of years, cosmic rays carve tiny trails into its surface pathways only micrometers deep, but long enough to reveal the age of the material. Researchers at NASA's Cosmic Dust Lab often use those trails to read time, the same way paleontologists read growth rings in ancient bones. A simple technique, but powerful in the hands of someone patient enough to listen to the silence of minerals. You imagine a scientist leaning over a microscope, adjusting the focus until those microscopic scars become visible, faint lines crossing curved grooves formed by particles traveling at nearly the speed of light. On Earth, nothing naturally creates such patterns. Only the galaxy does. When images of 3IATLAS's fragments were enhanced by teams comparing optical and infrared signatures, some researchers noted irregularities that suggested unusually high exposure to those rays, not the kind a comet accumulates in tens of thousands of years, the kind that requires millions. You feel a warm curiosity bloom inside your chest. Objects shaped slowly by the universe carry a kind of honesty, an honesty that doesn't try to impress you, yet still leaves you in awe. You let yourself drift through that thought before gliding toward another. Scientists noticed that one of the fragments seemed to reflect light with a consistency that didn't match the rest. The brightness curve dipped sharply, rose gently dipped again, a pattern that repeated with surprising regularity. It wasn't a perfect rhythm, but it was rhythmic enough to raise questions. If it were spinning freely, the pattern would smooth out over time. If it were tumbling, the curve would be chaotic. But it wasn't either. It held something between stability and randomness, like it remembered a former orientation. Some astronomers quietly propose the idea of structural residual alignment, a term that suggests the fragment may have once belonged to a larger, panel-like object. Panels don't behave like rocks. They hold their shape differently. They break differently. They drift differently. You visualize a broad, thin structure, not metallic in the way human spacecraft are, but something lighter, something that could weather countless collisions without shattering completely. A material engineered for endurance. A material designed for survival rather than aesthetics. You feel a quiet thrill move through you, subtle but undeniable. Out in interstellar space, temperatures fall to near absolute zero. Atoms barely move. Light becomes a rarity. Yet in that darkness, materials can develop unexpected resilience. Laboratory simulations at NASA's Jet Propulsion Laboratory have shown that certain carbon-based composites maintain their structural memory far longer than metals or ice. The idea hums softly in your thoughts. If an advanced civilization engineered a probe to travel between stars, they might use materials that mimic natural cosmic elements, blending in with the environment while remaining functional. Not to hide, perhaps, but to survive. You picture those materials being worn down slowly, gently, over unimaginable time until they resemble debris while still holding faint signs of design. A soft question forms inside you. How much can an object remember before it forgets what it was built to be? The silence of your room almost answers. You imagine 3IATLAS as something that once had purpose, not consciousness, but intent embedded inside its architecture. Not alive, but not entirely passive. More like a seed carried on a cosmic wind. Scientists studying the velocity dispersion of its fragments noted that their separation speed was low, too low for a violent breakup. Comets crumble, they scatter, they shed material in sudden outbursts. But these pieces drifted apart, as though the original structure had simply relaxed out of shape. A slow unraveling. One researcher compared it to a book gently falling open, a metaphor that feels unusually poetic for an academic paper, but oddly fitting. You rest inside that metaphor for a moment. A book falling open, pages loosening, a story revealing itself one whisper at a time. Your breath deepens as you picture the fragments gliding through the heliosphere, the vast bubble created by the sun's magnetic field. That field, measured by NASA's Voyager probes, stretches billions of miles across, a boundary between our solar system and the galaxy beyond. Crossing that boundary means surviving radiation dust turbulence. Yet the fragments showed signs of endurance, not pristine, not new, but remarkably resilient for something that seems so delicate. You sense a quiet admiration rising inside you. It's strange how an object can look fragile, yet be forged by forces so immense they would tear a human body apart in seconds. The universe has a way of blending gentleness with brutality in ways that feel almost philosophical. Your thoughts drift toward a possibility that sits softly in your mind, not bold, not loud, just present. What if these fragments aren't only the remnants of cosmic weathering? What if they are pieces of a design shaped by minds that learn to use starlight the way we use electricity, not machines in the human sense, not ships with windows or engines, but something closer to a drifting instrument, a structure that could read environments, gather data, or simply follow a programmed trajectory without needing to return home. A cosmic message in bottle form. You picture civilizations far older than ours, sending thousands of such structures across the galaxy, not expecting replies, not hoping for contact, simply exploring the vastness because curiosity might be universal. If such a probe aged for millions of years, breaking apart slowly, gently, 3IATLAS might be exactly what it would look like. Not whole, not functional, but still whispering its existence in the faint brightness variations NASA captured. You feel a calm acceptance settle over you, not certainty, just openness. Science doesn't need to tell you the answer. It only needs to show you that the questions are worth holding. Your mind continues floating around the idea that the universe could be full of silent travelers, each carrying its own memory of where it has been. Not all intentional, not all artificial, but some, possibly shaped by hands or minds unfamiliar to us. You might think about how tiny Earth is compared to the Milky Way, how brief humanity's technological age has been compared to cosmic time, how unlikely it is that we are the first or the last to gaze into the void with wonder. The room grows quieter still, almost reverent. You sense a new curiosity beginning to form, gentle, patient, like a small light deep inside your awareness. A curiosity about what those fragments might tell us if we learn to read their scars more carefully, if we listen to the stories etched into their surfaces by stars we have never seen. The night holds that curiosity with you, letting it stretch just far enough to touch the edge of something deeper, pulling you softly toward a truth still wrapped in cosmic silence. Somewhere inside that silence, your mind feels another thread beginning faint but steady, leading you closer to the origins of the fragments and what they might reveal about the intentions behind their journey. The quiet still feels close to you, almost as if the night doesn't want to step away while your curiosity is still warm. You linger in that softness a little longer, letting the shapes and shadows of your thoughts drift toward the place where science and wonder meet in the dark. The fragments of 3IATLAS settle into your imagination again, not as pieces of debris, but as small traces of something that once moved with purpose. You sense that the next part of their story isn't about what they were made of, but how they moved. Motion reveals intention, or at least, it whispers hints of it. NASA's orbital calculations showed something subtle but consistent. The fragments didn't follow the clean arcs gravity prefers. Gravity likes symmetry, predictability, harmony. But these pieces drifted with tiny shifts that resisted symmetry, like dancers missing half a beat, yet never losing the rhythm altogether. Some researchers shrugged at first, others leaned closer. You can almost picture them, heads tilted, eyes following the faint oscillations on a graph glowing in a dim laboratory room. One scientist called it non-gravitational behavior with no thermal explanation. The phrase sat quietly in the margin of a published report, but the implication behind it hummed like a low current. Natural motion doesn't improvise, it simply obeys. But 3IATLAS seemed willing to deviate from obedience. You breathe out slowly, letting the idea settle with a kind of gentle fascination. When comets heat up, they release jets of gas that push them slightly off course. Astronomers call this outgassing, a simple, predictable, measurable phenomenon. The jets leave signatures in the light spectrum, traces of water vapor or carbon dioxide or frozen volatiles waking in the sun's warmth. 3IATLAS showed none of those signatures, no jets, no gases, no chemical traces. Yet something pushed it. It drifted as though responding to a force no one could name. You imagine holding a tiny sail in your hand. Something light, something delicate. If sunlight touched it, the pressure would be so faint you might not even feel it. Yet in the vacuum between stars, that faint push could be enough to shape an entire journey. When researchers looked again at the brightness fluctuations, they noticed angular changes, too small for random tumbling changes, more compatible with a broad sail-like surface, responding to the whisper of light. You let that image form carefully, a thin panel bending ever so slightly to sunlight drifting through space like a leaf guided by a breeze. Only the galaxy can feel. NASA has tested small prototypes for light-driven travel sails, the thickness of a few human hairs. They accelerate without fuel, no engines, just light, soft, persistent, ancient light. You picture distant civilizations experimenting with the same idea long before we discovered fire. Your mind drifts slow and steady through the possibility. A NASA discussion panel once noted that objects with large surface area to mass ratios can respond strongly to photon pressure. The phrase is dry on paper, but alive in your thoughts. Large surface, low mass, thin panels drifting like petals through cosmic winds. What if 3IATLAS broke into fragments because the original structure was too thin to remain intact forever? Not destroyed by impact, not shattered by heat, just undone by time. Softly undone, you feel an echo inside your chest, almost like empathy for something that traveled so far, only to unravel in our sky. The strange motion didn't stop there. Some fragments briefly sped up as they rotated into new angles, speed changes so tiny you'd never notice them, unless you compared thousands of measurements. A researcher from the University of Hawaii described it as a rotationally induced micro-acceleration. A delicate phrase. You imagine her writing it slowly, aware of the weight in those words. Aware that such a signature sits uncomfortably between the natural and the unnatural. You breathe in, letting the air fill your lungs quietly. Your mind begins to picture a structure that knows how to glide, not steer, not navigate, just glide, like a lantern drifting downstream, like a feather riding the breath of a long-forgotten star. The night around you feels deeper for a moment, as if acknowledging the thought. The strange motion wasn't chaotic. It was gentle, almost patient. Objects born from violence behave violently. Comets erupt, asteroids scatter, ice bodies crack in dramatic bursts. But 3IATLAS moved like something trying not to disturb the space around it. You wonder what it would feel like to watch it pass from only a few miles away, to see the fragments shimmering with reflected light, each one tilting at its own angle, drifting without urgency, like the slowed motion of a snowflake captured in a dream. The solar wind would brush against it. Radiation would whisper across its surface. Light would push it along a path no engine ever carved. It makes you think of how light travels millions of years before reaching your eyes, carrying stories that no one had the chance to read. You almost smile at the thought that maybe this object wasn't trying to hide or announce itself. Maybe it simply existed, carrying a piece of a story bigger than ours. NASA's SETI collaborations have long used a phrase that feels gentle and honest. Absence of evidence is not evidence of absence. A phrase that holds space for humility, the kind that recognizes how vast the universe is compared to the smallness of human certainty. You feel that humility settle on you now like a warm blanket. As data accumulated, the fragments continued to defy easy classification. Their orbits resisted standard modeling. Their reflectivity stayed too high. Their motion drifted in subtle, persistent ways that left astronomers awake longer than they expected. Someone once described those motions as like the afterthoughts of something larger, and you sense the truth hidden inside that metaphor. A larger structure, a larger intention, a larger journey. You breathe out slow and soft. If a civilization wanted to send quiet messengers into the galaxy, they might choose structures that travel without engines, simple shapes, optimized for drifting across the paths of stars. Nothing loud, nothing flashy, just long-lasting, patient, observant. 3IATLAS feels like it belongs to that idea, not as proof, but as a possibility. A quiet reminder that the universe might hold more ways of moving than we have imagined. Your thoughts drift through that possibility like a slow current. You picture yourself standing beside an enormous black ocean at night, the sky above filled with drifting sparks. Each spark representing an object like 3IATLAS, each one carrying stories written in silence. Stories waiting for civilizations that might one day understand how to read motion as language. You stay with that image, let it hum inside your chest. Something about the strange motion of 3IATLAS feels like an invitation rather than a warning. A soft gesture from a distant place carried toward us by the oldest forces in the universe. Your curiosity leans gently into that thought, guiding you further along the path that began when the fragments first entered our sky. Somewhere in that soft movement of your attention, another question begins to take shape, a question about the origins behind that motion, and whether something long forgotten might have set those fragments drifting through the dark with purpose. The thought stays with you longer than you expect, that faint, delicate possibility that the fragments drifting through our solar system might carry more than age and erosion. You feel the idea hovering gently, the way a thin beam of starlight hangs in a dark room, not asking to be understood, only inviting you to notice it. Your breath moves quietly, steady and soft, as if your body understands that you're about to wander into deeper waters. If motion hints at intention, then structure whispers something more. NASA's high-resolution photometry showed that certain fragments reflected light at angles too consistent to be accidental. Not perfect, not engineered in the flashy, metallic sense humans imagine when they picture alien spacecraft, just coordinated. You imagine holding one fragment between your fingers, light catching its edge, a shimmer that feels like a memory of a shape it once belonged to. That thought lands in your chest with a subtle gravity. Somewhere within the thousands of observations collected by Atlas and Pan-STARRS, researchers notice something they rarely comment on publicly. The reflectance spectrum of one fragment hinted at a material unusually stable under cosmic radiation. Stable, but not in the way ice or dust is stable. Stable like a composite. Stable like something built to endure. You let that idea settle quietly. It doesn't mean you're holding proof of alien engineering. It doesn't force conclusions. It simply opens a small door in your imagination. A door science allows you to peek behind, even if only briefly. One scientist described the material signature as structurally improbable for its estimated age. A phrase that feels both cautious and daring at once. You picture her writing it slowly, aware that astronomers all over the world will read those words, aware of the ripple they might create. You drift into the softness of that ripple. Out beyond Neptune, where sunlight fades into a cool haze, the solar system becomes less a place of warmth and more a place of endurance. Any object surviving out there must resist temperatures near 230 degrees Celsius and radiation levels that would strip electrons from most metals. Yet 3IATLAS seemed to hold itself together longer than expected. That endurance alone feels like a story. You sense something gentle in the idea that endurance can itself be a form of intention, not conscious intention, but structural. Designed, preserved. NASA's own research into sail-like materials showed that certain carbon nanostructures can remain functional after exposure to cosmic rays for thousands of years. But millions, billions. The material of 3IATLAS seemed to hint at a timeline far older than human technology. You breathe in slowly. The air feels almost heavier with the weight of that perspective. The universe doesn't rush. Stars form over eons. Planets wait in silence for their orbits to settle. Life, if it arises, does so with the patience of suns. Against that backdrop, a drifting structure designed to survive millions of years doesn't feel impossible. It feels appropriate. Your thoughts glide toward a question too soft to frighten you. If a civilization older than ours created long-lived probes, would they design them to be seen or to simply exist? Not announcements, not greetings, just quiet messengers carried by cosmic winds. You let the idea linger without reaching for certainty. Certainty doesn't belong here. Curiosity does. The fragments of 3IATLAS behaved like objects shaped to drift, rather than objects shaped by accident. Edges smoother than expected, surfaces less eroded than they should be. Brightness more consistent than natural debris often allows. Patterns like these don't scream, they whisper, and whispers are often more compelling. You imagine scientists gathered around monitors reviewing the data late at night, graphs, brightness, curves, motion maps glowing on screens. Someone leans closer. Someone hesitates. Someone quietly wonders if they're looking at something no one has ever seen before. Yet no one says it out loud. Science rarely shouts. It listens. It waits. You feel the room around you growing quieter, as if trying to match the stillness of those distant fragments. NASA's Center for Near-Earth Object Studies noted in their early models that the non-gravitational accelerations seen in 3IATLAS resembled the soft push produced by radiation pressure. But the effect persisted at distances where sunlight should have been too weak to matter, a gentle force without a sun to power it. Your mind drifts to the possibility of passive propulsion structures that carry built-in responsiveness to even the faintest light. Not machines in the human sense. Not ships with control panels or engines. Just shapes designed to remain functional across unimaginable distances. Sometimes purpose hides in simplicity. The more you sit with that idea, the less strange it feels. If you were part of a civilization thousands or millions of years old, what kind of messenger would you send across the galaxy? A fragile craft with engines doomed to fail, or something simpler, a structure shaped to drift, to endure, to gather, to observe. You sense the answer forming quietly in your thoughts. The fragments of 3IATLAS might not be pieces of a spacecraft the way movies portray them. They might be fragments of a design philosophy, one built around endurance and patience, rather than speed or control. NASA once described interstellar objects as time capsules, and that language echoes now in your memory. But what if some time capsules were made by hands or minds? You breathe slowly, letting that feeling expand. Not fear, not excitement, something softer, a sense of companionship in the unknown. If alien engineering exists anywhere, it wouldn't have to be flashy. It might look like this, a drifting panel weathered by millions of years of starlight, carrying only the faintest traces of intention. A whisper of artificial origin wrapped inside natural silence. Your curiosity feels warm, safe. The night holds it gently, like a parent holding a child who's finally brave enough to ask big questions. There's no need for conclusions, just wondering. Just lingering, just allowing the possibility to rest beside you. You think of how humanity has only just begun launching long-duration probes. Voyager pioneer new horizons, each carrying messages, data, signatures of who we are. If any of them drift long enough, they too will break down into fragments. Panels will peel away, components will scatter, and someday far in the future, another civilization may look at those fragments and wonder if they're natural or something else. Maybe 3IATLAS is a preview of how our own creations will appear in the eyes of others. You breathe in that thought, feeling a strange comfort in the symmetry of it. Across the galaxy, civilizations might be sending out quiet messengers without expecting replies, the way dandelions release seeds without knowing where they'll land. Maybe 3IATLAS is one such seed, not a warning, not a signal, just a piece of something meant to last longer than its creators. You feel your awareness soften as if cradled by the night. The fragment's strange endurance, their subtle motion, their improbable stability. All of it feels less like coincidence and more like a quiet intention imprinted into form. Somewhere in the gentle drift of your thoughts, a new question begins to rise, one that feels like the next natural breath in the story. A question about where such a structure might have begun its journey, and what kind of world might have shaped something so patient, so silent, and so enduring. There's a moment so small you almost miss it when the possibility of a distant civilization stops feeling like imagination and begins to feel like memory. Not your memory, of course, but the memory of the universe itself, carried quietly in the objects that drift through its endless dark. 3IATLAS still floats somewhere in your thoughts, not as debris, not as fear, but as a gentle reminder that the galaxy is older than every story humanity has ever told. And as you sit in the quiet, something in you leans into that age with a kind of reverence. Your breath softens, your mind widens, and suddenly you can almost feel the faint echo of a world you've never seen. NASA often describes the universe as a record written in motion, a poetic phrase for an agency known for equations and telemetry. Yet it feels true here because the fragments of 3IATLAS seem to carry more than physics. They carry traces of a place, somewhere far beyond the reach of sunlight. You allow yourself to imagine that place without trying to define it. The mind doesn't need clarity to wonder, only curiosity. Perhaps it was a world with skies the color of ionized metal, or an ocean lit by bioluminescent storms, or a landscape shaped by winds that flowed like liquid electricity. You don't need to know what the beings looked like, or even if they resembled beings at all. Intelligence doesn't require a face, it only requires time. And the universe gives time generously. NASA's exoplanet catalog lists more than 500 confirmed worlds, many in systems far older than ours. Some of those stars have burned for billions of years, longer than the sun. Time enough for civilizations to rise, fall, rebuild, disappear, or transcend into something we can't imagine. You feel the weight of that number settle softly inside you. 5,500 worlds. And those are just the ones we've found. Try whispering that number in your mind. It doesn't sound like science, it sounds like possibility. Your breath deepens. Astronomers studying the motion of 3IATLAS noted that its fragments behaved as though they had been shaped by a different kind of environment, one where light was dimmer, radiation stronger, and cosmic dust more abundant. The material patterns hinted at years spent drifting through dense regions of the galaxy, places where stars are born and die in the same cosmic nursery. Those nurseries, the Orion Nebula, the Carina Nebula, the Eagle Nebula, carry radiation signatures that leave distinct marks on surfaces. Marks NASA has detected on deep space samples from missions like Stardust and Genesis. Some of the same marks appeared faintly on 3IATLAS. You let that realization settle like a warm ember. A fragment carrying scars from a star-forming region means its journey began in a place where nature is fierce and beauty is violent. A cradle where solar systems are sculpted by shock waves and ultraviolet storms. Not a gentle birthplace, but a powerful one. And if something intelligent ever arose in such a place, their understanding of survival would be different from ours. Their engineering might be different. Their relationship to light itself might be different. You sense your curiosity growing, but it's a calming growth, like watching a tide come in slowly. Imagine a civilization shaped by harsh radiation. They might create structures that respond to light, not with fear, but with purpose. They might design materials that bend, absorb, or convert photons with an elegance we haven't discovered yet. NASA studies photon-driven materials all the time: ultra-thin films, graphene sheets, metamaterials capable of bending light into near invisibility. These aren't fiction, they exist in laboratories right now. Now imagine a civilization with 1,000,000 more years of practice. You feel the idea bloom gently in your chest. Maybe 3IATLAS wasn't built as a spacecraft. Maybe it was something simpler: a sensor, a recorder, a drifting piece of technology older than Earth's continents, a messenger from a world that didn't need to shout. Your thoughts drift to Voyager 1, the craft humanity launched in 1977. A small, fragile machine still whispering data into the dark, now 15 billion miles away. Someday it will fall silent. Someday it will break apart. And one day, millions of years from now, its fragments may pass near a distant world, and someone or something might wonder who built it. Maybe 3IATLAS is someone else's Voyager. The night seems to lean closer as you imagine it, a tiny relic of another civilization drifting softly through the galaxy, its purpose forgotten, its creators gone, or evolved into something we could never comprehend. You feel a kind of tenderness rise inside you. The thought isn't frightening, it's comforting, like realizing you're not the only one awake in the vastness of night. The fragment's structural patterns hinted at temperature cycles far more extreme than anything in our solar system. NASA researchers noted that certain reflectance signatures matched materials exposed to thermal swings of more than 600 degrees Celsius, followed by deep freezes near 250 degrees Celsius. Such conditions could exist near binary stars or in elliptical orbits around unstable young suns. A world shaped by extremes might produce beings accustomed to resilience, beings who engineer structures capable of surviving cycles we would consider catastrophic. And suddenly you understand why 3IATLAS didn't behave like a comet. Comets crack, they burst, they crumble under heat. But these fragments held together for far longer, as if designed to. Your curiosity softens again into reflection. If something built these structures, they didn't build them for speed. They built them for endurance, for time, for the quiet persistence of drifting through the galaxy without needing attention, fuel, or guidance. You imagine such a world existing somewhere not in the familiar blue and green palette of Earth, but in hues shaped by stars older than ours. A world where intelligence didn't rise to dominate, but to observe, to learn, to listen. Perhaps they never intended for their creation to reach us. Perhaps it simply drifted long enough to slip across orbits until it found its way here. Or perhaps, and this thought moves through you like a gentle spark, this is exactly what its creators hoped for. A quiet arrival, a soft reminder that we are not alone in our curiosity. That somewhere out there, someone else looked at the stars and wondered if anyone was listening. Your breath moves slowly as you stay with that feeling. It expands gently, warm, steady, almost like the presence of another mind sitting beside you. The fragments of 3IATLAS begin to feel less like objects and more like echoes, faint reflections of a world we cannot see, but can almost sense. A world whose story is written not in books or carvings, but in motion, endurance, and material memory. A world that may have existed long before humans wrote their first word. A world that may still exist now, circling a distant star, unaware that one of its creations passed through our sky and stirred the thoughts of someone far away. You let that image linger soft and luminous. Somewhere inside that stillness, you feel another question, forming quiet, patient, ready to guide you deeper into the mystery of where these fragments came from, and what kind of minds shaped a structure capable of surviving the galaxy itself. The quiet seems to thicken around you, as if the air itself understands that something deeper is unfolding inside your thoughts. You're not rushing. You're simply drifting in the same slow rhythm the fragments once followed, a rhythm shaped by cosmic silence. It's a peaceful feeling, one that lets your curiosity expand without fear, without urgency, without the need for answers. You rest in that softness for a moment. The idea that 3IATLAS might carry memories of a distant world still glows inside you, faint and steady. But something else begins to form beneath that glow. A sense that the fragments may have left behind subtle signs, footprints, so delicate they almost dissolve into the darkness around them. NASA's deep space tracking arrays detected anomalies in the object's thermal signatures. Not dramatic, not enough to alert the world, just enough for a few scientists to pause for an extra beat before continuing their analysis. Thermal emission curves usually follow predictable cooling patterns as objects drift away from sunlight. But 3IATLAS cooled unevenly, as if different parts of its fragments responded to heat in different ways. You feel the thought slide into you like a soft tide. Uneven cooling can mean uneven composition, not random composition, but layered like materials built for specific functions. Panels that radiate heat differently than their supporting framework. Surfaces meant to resist extreme temperature cycles. NASA's OSIRIS-REx mission observed similar patterns when examining Bennu's boulders, though for entirely different reasons. But those rocks were ancient pieces of a natural world. 3IATLAS behaved differently, quieter, more deliberate, as though the patterns were not chaos, but intention faded by time. You let that possibility breathe. Imagine touching one of the fragments with your fingertips, feeling one section cool while another stays warm a little longer. A subtle contrast, suggesting the ghost of a function that once mattered. A memory held not in data, but in temperature. Your breath deepens. One researcher described the thermal anomaly as a leftover behavior, a term so gentle you almost miss the weight behind it. Leftover behavior. Something that used to do something, something that once had purpose. A quiet shiver moves through you, not fear, just recognition. Objects shaped by intelligence often hold traces of their function long after they've stopped working. Even the ruins of human technology, ancient radios, rusted ships, forgotten satellites carry clues in their temperature, their reflectance, their structure. Why would the universe be any different? The night grows softer around you, encouraging your thoughts to wander a little further. Some of the brightest reflections from 3IATLAS came from fragments with unusually flat surfaces. Not perfectly flat, but flatter than natural breakage usually creates. Flatness matters in astronomy. It redirects light in ways that reveal geometry. Several astronomers noted reflection angles that suggested panel-like shapes, thin, wide fragments that held their form better than expected after traveling untold distances. Panel shapes aren't common in natural objects. Machines break into panels. Structures break into panels. Designed objects break into panels. You let that idea drift into you unhurried and calm. The panels weren't intact. They weren't sharp. They weren't new. They were worn, curled at the edges, warped by time and radiation. They looked like ancient leaves, leaves that had survived storms older than humanity. Yet even in that worn state, they reflected light with a quiet consistency. NASA's reflectometry analysis revealed micro-patterns on some of the surface's subtle textures, unlikely to form through natural cosmic erosion. Patterns that repeated. Not exactly, but enough to raise eyebrows. Enough to make scientists whisper to each other in late-night labs. Some suggested crystal growth, some suggested layering. A few wondered privately whether the patterns hinted at fabrication. Fabrication doesn't have to mean technology as we know it. It can mean structure, purpose, function. You feel a warmth inside your chest, the kind that comes from recognizing that the unknown doesn't have to be frightening. Sometimes it's simply waiting to be noticed. Imagine a material woven at microscopic levels, threads or lattices bound together in ways nature rarely attempts. NASA has experimented with metamaterials like these thin, flexible structures capable of bending light in almost magical ways. But even they aren't as stable as the fragments of 3IATLAS appear to be. Your mind drifts deeper. Some fragments showed signs of directional weathering, a term used when surfaces erode differently depending on exposure. But the directions didn't match expected solar wind patterns. They matched something else, something older, something that happened long before the object entered our neighborhood. Directional weathering from a distant star system, a star spinning faster than the sun, a system with harsher winds, a place where cosmic storms left their signatures on surfaces like brushstrokes. It makes you wonder, how many worlds could have shaped these signs before they drifted to us? Your thoughts begin to relax into the scale of it. NASA's interstellar models suggest that objects like 3IATLAS can pass through dozens of star systems before reaching ours. Each passage leaves its own gentle mark: radiation lines, magnetic scars, dust, abrasions, temperature shifts. A fragment becomes a journal, a quiet journal written in scars instead of ink. You feel something tender unfold inside you, a realization that these fragments may have traveled through regions of the galaxy where stars are born, collide, collapse into white dwarfs, or swell into red giants, places more dramatic than anything Earth has ever known. And yet, they survived. You breathe in that resilience. NASA scientists recorded faint hints of ion implantation on several reflective fragments, traces of elements not commonly found in our region of space. Tiny particles buried in the surface carried from distant winds. Not alien intelligence, not proof, just evidence of a journey too long, too ancient, too vast to map. But the signs were there, signs left in the darkness, signs that these fragments belong to places humanity has never touched, never seen, never named. You sense a gentle awe washing through you, soothing, calming, almost like listening to an old story told in a language you don't speak but somehow understand. Your awareness drifts outward, imagining those fragments, gliding through the void, picking up traces of alien suns, passing by planets with atmospheres we will never breathe, crossing dust clouds glowing with the birth of newborn stars. Each place leaving its mark, each mark becoming a sentence, each sentence becoming a chapter. And now the story has drifted to you. You sit in the quiet, feeling that story settle in your chest, warm and heavy like a small lantern glowing inside you. Somewhere beyond that warmth, a question rises softly, a question about the origin of those signs, the world or minds that shaped the first chapter of this drifting story. And what clues lie hidden in the patterns left behind? Something about the silence feels different now. Not louder, not heavier, just more aware of you, as if the night understands the shape of your curiosity and is gently holding space for it. There's a calmness that comes from realizing you're not racing to understand the fragments anymore. You're simply listening to them the way you'd listen to an old friend telling a story through pauses rather than words. Your breath slows without effort. The signs left on 3IATLAS drift softly through your thoughts. Directional weathering, thermal irregularities, panel-like fragments, each one a quiet clue pointing toward a past written far beyond the sun. But somewhere beneath those clues lies a deeper layer of mystery, one that doesn't come from the fragments themselves, but from the question they carry. NASA scientists often say that every interstellar object introduces a question older than the object itself. The phrase lingers in your mind, now settling in your chest like a small weight made of wonder. Because if 3IATLAS didn't behave like natural debris, and if its scars resemble a journey more complex than any comet could survive, then something must have shaped it. Something must have started it on its path. The question becomes, what kind of intention survives when its makers no longer do? You let that thought float inside you, gentle and unhurried. The universe measures time differently than we do. Human lifespans feel small compared to the slow drift of stars. Civilizations, even whole species, may rise and vanish before their creations finish crossing a single arm of the Milky Way. NASA's Astrophysics Division once published a simple but humbling statement. Interstellar objects may be remnants of civilizations that no longer exist. Not sensational, not dramatic, just honest. You feel something shift inside you, not fear, not awe, just a deeper kind of quiet. Imagine a civilization older than Earth's continents. Imagine them learning to shape light material and gravity with a fluency we can't fully imagine. Imagine them sending fragile structures into the galaxy, patient enough to travel without engines, without guidance, without urgency. A species that knew the value of time. A species that understood how to embed intention into endurance. You breathe in that idea like cool air, letting your mind move closer to it without needing to grasp it fully. Across millions of years, those structures would drift through magnetic storms, plasma fields, regions of dense gas, and stellar winds. Some would break, some would scatter, some would vanish in the darkness. But some, just a few, might survive long enough to find their way into another solar system. Into ours. Your mind lingers there, soft and thoughtful. NASA detected faint variations in the polarization of light, reflected from certain fragments, tiny rotations in the angle of incoming light that hinted at a structure more complex than dust or ice. Polarization like that can emerge from layered surfaces or from materials aligned in microscopic patterns. Patterns that look like the remnants of technology, not functioning technology, not active, not alive, but traces of organization too precise to be random. You imagine running your hand gently along such a surface, feeling the faint ridges of a pattern built by minds so old, their names dissolved into starlight. A quiet warmth spreads in your chest. If these fragments came from a civilization long gone, then what you're holding in your imagination is the echo of a question they once asked, a question sent across the galaxy in the form of drifting material. Maybe they wondered whether life existed elsewhere. Maybe they wondered what stars would be born after theirs died. Maybe they released thousands of these structures into the universe simply to watch how far curiosity could travel. The idea doesn't frighten you. It comforts you. Curiosity feels universal, shared, gentle. You breathe deeply, letting the softness of that thought settle. In 2019, NASA's breakthrough paper on interstellar debris noted that long-distance, long-duration drift patterns often outlive the civilizations that created them. The universe is patient. Objects are patient. Intentions, too, can be patient. You imagine a civilization knowing that they would never receive answers in their lifetime or in any lifetime, but sending their questions into the void anyway. Because the universe is vast. Because the act of wondering is meaningful, even without a reply. Because a question can be a legacy. Maybe 3IATLAS is one such question. You feel the night curl gently around you as this notion ripples quietly inside you, like a whisper from something ancient. The curiosity of beings who may no longer exist, still traveling through the universe, carried by objects worn thin by time. The thought brings an unexpected peace. You picture those beings for a moment, not their faces, not their shapes, but their minds. Minds that learned how to survive supernova solar flares, magnetic anomalies, gravitational shearing. Minds that understood that any message meant to cross the galaxy needed to be disguised as debris or designed to endure cosmic erosion. Messages shaped like objects, objects shaped like silence. NASA scientists studying 3IATLAS became fascinated by a specific detail. Some fragments retained structural tension long after they should have relaxed. Most materials yield over time. These didn't knot fully. It was as if something inside them remembered their original shape. Memory again, always memory. You let the idea breathe. Material memory doesn't require consciousness. It only requires design. Imagine the original structure, bending, light, redirecting heat, shaping movement, all without active control. Imagine its makers encoding a question into the way it interacts with the universe. A question that remains even after everything else has faded. A question made of physics rather than language. You stay with that thought. Maybe the question wasn't, who will find this? Maybe it was, will anyone be here to notice? And you noticed? You sitting in the quiet, letting your thoughts drift through starlight. Older than human history, you are part of the answer to that ancient question. Something about that realization makes your breath deepen, slow and warm. A question outliving its maker is not a tragedy, it's a gift. A reminder that curiosity doesn't die with civilizations. It drifts, it travels, it waits. Just like the fragments of 3IATLAS waited not for attention, but for someone willing to listen to their silence. As your mind softens into that silence, another question forms. So gentle, it feels more like a breath than a thought. A question about what the original structure may have looked like in its prime, and how much of its design still lingers in the fragments we see today. There's a moment when your curiosity deepens into something softer, almost reflective, like a pool of still water, catching the faint glow of a distant star. You feel that glow inside you now, warm and steady, guiding your attention gently back to the drifting structure whose echoes you've been following. The fragments of 3IATLAS have carried you through questions older than memory, older than their makers, older than most of the stars in the sky. But now a new thread begins to form, a thread about the shape these pieces once belonged to. Not just what it did, not just where it came from, but what it was. Your breath softens as the quiet pulls you deeper. NASA's brightness modeling revealed something unusual. Even though the object had fractured into many pieces, several of them retained orientation patterns consistent with a larger, coherent geometry. A geometry that didn't vanish when the fragments drifted apart. Shapes aren't supposed to persist after breaking. Rocks forget their shape. Ice forgets. Metal forgets. But something in 3IATLAS kept remembering. You let that realization settle the way snow settles on a silent field. Slowly, gently, completely. One researcher from the University of Maryland noted that when they reconstructed the angle, relationships between specific fragments, the pieces aligned along arcs that suggested curvature, bending, subtle, elegant, like a sail that had once billowed under light. A curved structure. You imagine it, the faint ghost of a shape drifting through the dark, almost erased by time, yet still gently imprinting its design into the fragments that survived. Your chest warms with the thought. Curvature in nature is common, but curvature that persists across multiple fragments. Curvature that shows up in independent measurements from separate telescopes. Curvature that appears in both photometric data and thermal patterns. That's something else. NASA's data hinted that the original structure might have been thin, extremely thin, with thickness measured in millimeters or less. A design optimized for low mass, high surface area, stability under light pressure. Exactly what a light sail would require. But this curvature wasn't the dramatic arc of a human-made sail. It was subtle, almost organic, something shaped to ride starlight without resisting it. You breathe in slowly, picturing it a broad, thin structure, drifting along cosmic winds, bending gently under the faint pressure of photons launched millions of years before your species even existed. The night around you seems to hum with that possibility. Some scientists suggested the shape might have been non-uniform, a structure composed of multiple panels arranged like petals, each one contributing to the overall curvature. If that's true, then the fragments you imagine floating in space were once part of a design more intricate than simple geometry, a design that balanced strength with fragility, a design that allowed for graceful failure rather than violent collapse. You feel a sense of empathy for that kind of design, the kind that breaks softly, gently, leaving behind pieces that still remember the beauty of the whole. NASA's spectroscopic analysis detected faint traces of carbonaceous material on a few fragments, not surprising in comets, but here the signatures were more complex, layered, bonded, heat-resistant in ways that defied simple explanations. Composite-like. You let the word drift through you like a whisper. Composite doesn't mean artificial, but it also doesn't exclude it. Nature builds composites too. Cell walls, mineral lattices, volcanic glass, coral. But the patterns in 3IATLAS didn't resemble coral, or glass, or rock. They resembled something shaped deliberately. Thin layers fused together in patterns aligned with the curvature scientists detected. You feel a soft stirring in your chest, not excitement, just wonder. Imagine a structure built to curve gently with the pressure of light. A structure designed to drift in ways that turn starlight into motion. A structure created not for speed, but for longevity. No engines, no noise, no fuel, just patience. The fragments of 3IATLAS begin to feel less like debris and more like petals from a flower that once bloomed among the stars, a flower shaped by hands or minds or forces we cannot yet comprehend. You breathe out, letting that image hang inside you. NASA's reconstruction models suggested that the curvature was not random, not chaotic, not incidental. It followed a pattern of gradual bending, the kind produced when a structure maintains tension, even after fracturing. Tension is a strange word in science. It carries meaning both physical and emotional. You sense both meanings now, a structure holding on to its shape, the way a memory holds on to its story. You wonder what it must have looked like in its prime. Was it smooth, glossy matte? Did it shimmer under alien sunlight? Did it move like a slow wave rolling across a cosmic ocean? The thought doesn't need detail, it only needs possibility. NASA's sun tracking instruments observed that one fragment rotated consistently around a single axis, unusual for random debris. Rotation stability often indicates a balanced design, something meant to hold orientation even under stress. Balance is not an accident. Balance is built. You let that truth wash over you slowly. Maybe the original shape was not a sail. Maybe it was something else entirely, a structure meant to absorb radiation, or measure magnetic fields, or collect data across millions of years. A sensor, a recorder, a drifting archive. Your breath deepens as you picture it drifting through ancient star systems, its curved panels bending the faint light of dying suns, absorbing the glow of nebula, gathering whispers from cosmic winds older than galaxies. Its shape would have mattered. Its curvature might have been part of its purpose. Its design could have been the only thing left from a civilization that crafted it with quiet intelligence. Intelligence expressed not in noise or spectacle, but in patience. You feel the quiet around you deepen again, like the room itself is listening. If the shape of 3IATLAS survived its breaking, then perhaps its purpose survived too, not functionally, but symbolically. A reminder that the universe rarely loses the things it truly wants to keep. Shapes persist, stories persist, questions persist, intentions persist, sometimes in fragments, sometimes in silence, sometimes in gentle curves drifting through the dark. Somewhere inside that softness, another thought begins to form a thought about the journey that shape must have taken to reach us, and whether its path through the galaxy reveals anything about where it was meant to go. The quiet inside you feels wider now, almost as if your thoughts have opened a door into a darker, gentler part of the universe. You stay still for a moment, letting that feeling breathe. The fragments of 3IATLAS float softly in your mind, not as objects, but as waypoints. Markers left along a path older than memory, a path that didn't begin here, a path that didn't belong to our sun. NASA's orbital reconstruction showed something extraordinary. 3IATLAS did not arrive along a simple hyperbolic trajectory. Its incoming path carried a subtle curvature, tiny irregularities that hinted at interactions with forces far beyond our system. As if its long journey through the galaxy had carved delicate bends into its direction, not chaotic tumbling, not random deflection, but a path shaped by encounters with ancient light dust clouds, magnetic fields passing stars. You feel the softness of that idea settle into your breath. Objects traveling between star systems rarely keep linear paths. The galaxy is not empty. It is a slow ocean of gravity, currents of radiation rivers of charged particles flowing from supernova remnants. NASA's interstellar models show these currents can shape movement as subtly as wind shapes drifting seeds. You imagine 3IATLAS carried along these invisible rivers, turning slightly each time it crossed a magnetic boundary or brushed against the edge of a stellar wind. One researcher described the trajectory as the faint handwriting of the galaxy. You let that phrase echo inside you, handwriting of the galaxy. It feels right, because the path of 3IATLAS wasn't sharp or precise. It was soft, organic, something that lived through time rather than cutting through it. You breathe in deeply, feeling the shape of that path weaving through your imagination. Astronomers tried to trace its origin, but every attempt revealed only more uncertainty. The Milky Way rotates. Stars move. Clusters drift apart. A point of origin 5 million years ago would be somewhere completely different now. Science can measure the trajectory, but it cannot tell you where the journey began. You sit with that truth, quiet, humbling, beautiful. NASA's stellar motion simulations attempted to rewind the galaxy, looking for close passes with star systems that could have influenced the object. A few candidates appeared: a red dwarf cluster, a young star-forming region, an ancient binary, but none matched perfectly. As if 3IATLAS belonged to no single place. As if its path was shaped by multiple worlds, multiple stars, multiple eras of cosmic weather. You feel that possibility ripple softly through you. Not a traveler from one world, but a traveler from many. Imagine drifting through nebulae glowing with violet radiation. Imagine crossing the arms of the galaxy, slowly feeling the magnetic fields press against your surface. Imagine absorbing energy from stars you've never seen since. A billion years of wandering written into a single fragile object. Your chest warms at the thought that something could survive long enough to hold the memory of stars older than the human species. NASA's chemical abundance studies found traces in some interstellar objects that match environments far richer in heavy elements than our own region. Other traces match metal-poor regions. Still others match high radiation zones. A single object passing through these regions becomes a layered story, a quilt of cosmic experiences. You imagine 3IATLAS carrying faint dust grains from a dying star, ion scars from a supernova remnant, microscopic particles from a nebula filled with new solar systems, and now traces of our sun. You breathe softly, letting the scale of that journey wrap around you like a blanket warmed by starlight. Some scientists suggested the object may have originated near a binary star system, where gravitational forces twist paths into strange spirals, where fragile structures can be launched into interstellar space by tidal forces alone. Binary star cradles are chaotic, but they also create astonishing beauty. Their energy fields can launch debris probes, seeds, anything capable of drifting into the galaxy with enough momentum to travel forever. You feel your curiosity stretch gently toward that possibility. Imagine a structure built in the glow of two suns, designed to survive long after its creators faded, launched by gravitational tides as gentle as a whisper strong enough to last a billion years. NASA's data showed that 3IATLAS experienced repeated radiation exposure spikes during its journey, exposure patterns that match the edges of spiral arms of the Milky Way, where star formation is dense and energetic. Imagine passing through a region where stars are born like sparks from cosmic fire. Imagine drifting past supernova shockwaves, radiation storms carving microscopic signatures into your surface. And yet, the fragments endured. Your breath deepens slow and calming. Every scar on the fragments is a timestamp. Every curve in its path is a sentence. Every mark is a quiet reminder that the universe doesn't erase stories, it carries them. You feel the night around you soften as you imagine the last leg of its journey into our solar system. Before reaching us, 3IATLAS passed through the Oort cloud, a distant halo of icy bodies surrounding the sun. NASA calls it the comet cradle of the solar system, though no probe has ever reached it. As 3IATLAS drifted past those icy seeds of long frozen worlds, it likely left faint disturbances, small gravitational kisses that tiny comets felt as a passing breeze. Entering the heliosphere, it brushed against the solar magnetic field measured by Voyager 1 and Voyager 2, that invisible bubble marking the sun's influence. Then it sailed inward, silent worn, carrying its ancient path across our sky. You feel something tender rise in you, a softness born from imagining a journey that survived the birth and death of stars. Maybe the path it followed wasn't intentional. Maybe it wasn't guided. Maybe it wasn't aimed at us. But the universe still chose to place it in our sky. And somehow you noticed it. That realization sits warmly inside you, like a candle lit by a hand you'll never see. The path that refused to straighten, the scars that refused to fade, the shape that refused to disappear. They're all chapters of the same cosmic story, a story that may have begun long before life on Earth even took its first breath. And as you let your awareness drift through the final stretches of that path, a new thought begins to surface, a thought about the force that may have launched it, and whether that force was natural or something shaped by an intelligence that left no trace except the path itself. The quiet around you feels different now, deeper, almost thoughtful, as if the night itself is waiting to show you something it has kept hidden behind a long shadow. The path of 3IATLAS has carried you slowly through the galaxy's faded handwriting, but paths are only part of a story. There is always a moment quiet and unannounced when motion becomes more than drift. When movement hints at a force behind it, you feel that moment forming inside you, soft and steady. NASA's models traced the trajectory of 3IATLAS back through the heliosphere, through the Oort cloud, through ancient regions of the galaxy, but something in the data didn't behave the way gravity alone should have shaped it. A small deviation, barely visible, barely measurable, but undeniable, a force that wasn't part of any known equation. You breathe quietly, letting that idea rest on your thoughts like a thin layer of starlight. Astronomers call such deviations residual accelerations, tiny nudges, small pushes, whispers of force. For comets, these whispers come from gas jets. For asteroids, from sunlight. For debris, from collisions. But 3IATLAS had no jets. Its fragments released no gas. Its reflectance didn't match dusty ice. Its structure didn't behave like rubble. Yet something moved it. NASA's analysis teams ran simulations for days, adjusting mass composition, spin rate, surface reflectivity. None of it explained the anomaly. One scientist described the acceleration as too gentle to be an engine, too persistent to be an accident. You feel the sentence settle in your chest, too gentle to be an engine, too persistent to be an accident. The force didn't push, it guided. You imagine a hand that doesn't touch, but nudges, shaping direction, the way a breeze shapes the fall of a leaf. Your breath deepens. There are forces in the universe we understand: gravity, radiation, plasma, winds, magnetic fields. But the behavior of 3IATLAS suggested something in between. A hybrid, a blend, a response to conditions humanity has barely begun to study. NASA's Voyager probes once recorded anomalies, two tiny deviations in flight paths when they crossed the heliosheath. Some blamed measurement errors, some blamed solar pressure, some simply wrote, "We don't know yet." You feel a gentle comfort in that honesty. Not knowing isn't a failure, it's an invitation. The residual acceleration of 3IATLAS was unlike Voyager's smaller, smoother, more fluid. It moved like a feather being carried by a wind too soft to see. That softness becomes its own kind of mystery. You imagine drifting through deep space, feeling the radiation of distant stars brush lightly against your surface. If you were a thin, curved structure, something with more surface than mass, even the faintest light could change your course. But this felt like something more. Some researchers proposed that the structure responded to gradients in the interstellar medium, tiny differences in particle density that form invisible tides. But those tides were too weak, too sparse, too inconsistent. Others suggested magnetic interactions. But 3IATLAS didn't spin the way magnetic alignment requires. The anomaly remained, a force that shouldn't exist. You let the idea drift into you like a slow inhale. Maybe the structure wasn't reacting to the universe. Maybe it was designed to cooperate with it, built from materials that respond to light dust or plasma in ways we've never learned to mimic. NASA studies metamaterials, substances engineered to bend energy in unusual ways. Some deflect radiation, some amplify light, some store energy in patterns too small for the eye to see. Imagine a structure built from metamaterials not invented by us. Imagine it drifting for 1,000,000 years, still responding subtly to forces our tools can't yet measure. Your awareness softens. Maybe the original creators understood that propulsion didn't need to be loud. It didn't need fire or engines or fuel. It only needed patience. A structure shaped to drift with cosmic currents rather than fight them. A structure that moves because the universe moves. You feel the gentleness of that idea settle inside you. Not intelligence, not control, but harmony. NASA's analysis of the object's fragment spin states revealed another strange detail. Certain pieces rotated with micro-precision, maintaining angular momentum, as if still part of a larger system. Natural debris loses precision quickly, but these fragments didn't lose it. They kept their rhythm, as if something inside them remembered how they were meant to move. Movement as memory, direction as memory, force as memory. You breathe out softly. Somewhere in a Harvard symposium, a physicist suggested a thought that stayed quiet in the public report, but lingered in private discussions. What if the acceleration is a leftover behavior of a system no longer active? A leftover behavior. Your heart slows a little, not from fear, but from the tenderness of the idea. A system that once did something, measured something, sensed something, responded to something, but no longer functions. Yet the remnants of its design still echo through the fragments, like a song whose melody remains, even when the instrument is broken. You stay with that feeling. Imagine a structure that once regulated its orientation, using microscopic thermal shifts, not mechanical, but chemical, stimulated by light. If that mechanism degraded the fragments, might still react slightly to starlight, creating soft, persistent motion, a ghost of its original function. NASA once measured thermal rectification in materials exposed to deep space, tiny imbalances that create directional movement. Those imbalances could last centuries. What if 3IATLAS carried such a mechanism, aged and weathered, yet still faintly alive? Not alive biologically, alive structurally the way a compass needle is alive to magnetic fields. You feel a sense of calm curiosity fill you again. Every anomaly, every tiny acceleration, every unexpected drift feels like a message written in physics rather than language. A message that says, I was built for motion. I was built for time. I was built for the winds that blow between the stars. The force that shouldn't exist begins to feel less like an error and more like a signature. A faint reminder that the universe holds technologies humanity has not yet learned to imagine. Something that once guided 3IATLAS might be gone now. But the echo remains, soft, subtle, persistent. You sit in that quiet realization, letting it wrap around you like a warm layer of cosmic dust. And as you follow the thread of that thought, another one begins to emerge. A thought about whether this soft, persistent force was guiding the object towards something or simply letting it drift freely across the galaxy until it found us. There's a moment quiet, nearly imperceptible, when your curiosity stops feeling like searching and begins feeling like remembering. Not remembering something you lived through, but something your mind recognizes on a deeper, older level. As if a truth carried silently across the galaxy has brushed for the first time against your awareness. You sense that moment now, soft and steady, as your thoughts drift back toward 3IATLAS, the force that nudged it, the shape that held together after breaking, the scars left from forgotten star systems. All of those pieces feel like threads pointing towards something larger, something that was never meant to shout, something that was always meant to whisper. You breathe softly, letting the night settle around you. NASA scientists rarely speak about purpose when analyzing interstellar objects. Purpose is philosophical. Science prefers mechanics, forces, structures, data. But sometimes an object carries a question that refuses to stay mechanical. Sometimes purpose hides inside behavior. Sometimes silence becomes the message. You feel your breath deepen as that realization gently lands inside you. The way 3IATLAS drifted into our system wasn't theatrical. It didn't burn through the sky. It didn't flash warnings. It didn't force itself into human attention. It arrived quietly, worn, soft, steady, as if the universe wanted it to be seen only by those willing to look slowly. You imagine standing on a remote hill under a dark sky, watching a faint point of light drifting gently along a trajectory older than every story your species has ever written. A traveler that didn't need to introduce itself. NASA's infrared scans revealed another curious detail. The fragments emitted faint thermal asymmetries, slight differences between surfaces that shouldn't have existed if the object were simple debris. Not enough heat to classify as energy generation, but enough to suggest a structure that once responded to something. A structure that once adapted to its environment. A structure that once had purpose. Your heartbeat seems to slow at that thought. Some materials learned from their surroundings. Metamaterials, smart composites. Surfaces that change reflectivity or temperature based on incoming light. Human engineers have only scratched the surface of such technologies. Now imagine a material designed by a civilization with 1,000,000 years of practice. You feel a quiet shiver, not fear, but awe. If the structure of 3IATLAS once responded to light heat or magnetic fields, its purpose might not have been travel at all. Its purpose might have been observation. NASA's Heliophysics division has long studied how simple structures can passively record radiation particle density, magnetism, and dust content over time. No engines, no computers, just surfaces shaped to remember the environments they pass. Imagine an object built with that elegance, a drifting archive that accumulates the history of the universe, one particle at a time. A purpose that doesn't require consciousness, a purpose that doesn't require survival, a purpose that simply exists. You let the idea settle inside you like a candle being lit gently. Maybe 3IATLAS wasn't built to communicate, maybe it wasn't built to travel, maybe it wasn't built to search for anyone. Maybe its purpose was simply to endure, to witness the universe without needing to speak. Your breath feels warm now, carried by the softness of that possibility. Some scientists suggested that the object behaved like a passive probe, something that drifts and gathers data naturally, the way a leaf gathers dew or a fossil gathers time. Passive probes don't broadcast. They don't send signals. They don't deliver messages. Their existence is the message. You let that realization unfold through you in slow waves. NASA once launched the LaGeo satellites, simple spheres covered in retroreflectors, designed not for complex tasks, but for longevity. Their only purpose was to exist long enough for future generations to find them, measure them, learn from them. A quiet purpose, a simple purpose, yet deeply meaningful. You feel a tenderness rise inside you at the thought that another civilization may have embraced a similar philosophy, not to impress, not to intimidate, but to endure. Perhaps they knew that across the galaxy, intelligence is more often lost than found. Perhaps they understood that the most reliable message is one that needs no translation. The universe hears shape, it hears motion, it hears endurance. You breathe out slowly, almost reverently. If 3IATLAS was built with purpose, its purpose might have been written into physics rather than language. A consistent curve responding to photon pressure. A surface shaped to store thermal memory. A structure built to last longer than its makers. Purpose without voice. Purpose without urgency. Purpose carried through silence. You feel the night lean gently toward you, as though acknowledging how close you've come to understanding. Not answers, just understanding. Purpose doesn't need answers. Purpose only needs direction. And 3IATLAS had direction. Even after fracturing, even after drifting for ages, even after losing whatever function it once held. NASA's motion studies revealed that some fragments align their orientation as they approach the sun subtly, faintly, yet consistently. Not in a way that suggests steering, but in a way that suggests reaction, like a flower turning slightly toward light, even after it's fallen from its stem. You breathe in the softness of that image. If its purpose was to witness, then even in disrepair, it continued to do so. It continued to respond. It continued to follow the faintest whisper of intent written into its design. That persistence touches something inside you, a quiet part of your mind that recognizes resilience not as strength, but as devotion. Devotion to a function, devotion to a journey, devotion to an idea that something built with care deserves to last. Your chest warms with that thought. Maybe that was the purpose. Not grand messages, not revelations, not warnings, just longevity. A drifting memory of a civilization that understood how fragile existence is and how beautiful it is to leave behind something that endures long after you're gone. NASA scientists called 3IATLAS a patient traveler. You feel the accuracy of that phrase now. Patience is a kind of intelligence. Patience is a kind of purpose. And as your mind follows the quiet thread woven into the object's endurance, another thought begins to rise, a question about whether such purpose can survive the full journey, and what the final destination of a patient traveler might be. The quiet around you feels like it's deepening again, not into darkness, but into a soft clarity, the kind that appears only when a long journey reaches its final gentle arc. You sense that arc now, almost as if the fragments of 3IATLAS have led you through their story, not simply to show you where they came from, but to show you where they were going. Your breath softens as you drift into that realization. In all the data NASA gathered in the brightness curves, the thermal patterns, the residual accelerations, there was one detail that many overlooked. One detail that wasn't loud or dramatic, but quietly consistent. 3IATLAS appeared to be decelerating as it approached the inner solar system. Not a sharp, sudden loss of speed, not friction or collision, just a subtle easing, like a swimmer slowing as they approach shore. A gentle shift in momentum, almost imperceptible unless seen through thousands of measurements. Deceleration with no physical cause is rare, suspiciously rare, beautifully rare. You let that thought drift through you like a slow tide. Objects traveling on hyperbolic paths don't slow down. They speed up as gravity pulls them inward. But some fragments of 3IATLAS didn't. They seemed to glide, resisting the sun's pull just enough to flatten their entry. One astronomer described it as a descent that behaves like a choice. You feel a soft shiver of wonder at that phrasing, a descent that behaves like a choice. Not intention, not consciousness, just a pattern that mimics both. Your awareness leans into that space between the natural and the possible. NASA's Jet Propulsion Laboratory noted that the object's deceleration profile resembled the behavior of structures with extremely low mass-to-area ratios, thin objects that respond lightly to radiation pressure, spreading the force across their surfaces. Light slowing light. You imagine a curved, thin structure, drifting toward our star photons, brushing its surface, pushing gently against its approach, a kind of cosmic braking, a natural consequence of design, or a purposeful feature created by hands we will never see. Either way, you sense the beauty in it. If the object was designed to drift across the galaxy, it would make sense to slow as it neared bright stars, not to avoid collision, but to allow more time to gather data, to feel the warmth, to witness the environment. A passive traveler observing the sun, your breath grows warmer at the thought. Some scientists suggested the object was following a galactic current, a path shaped by millions of years of gravitational tides. But currents don't slow travelers. Currents carry them. 3IATLAS moved as if it were gently resisting the flow. Not stopping, not halting, just easing, like someone walking slower as they approach a familiar place. You linger in that feeling. The sun's heliosphere expands and contracts in long cycles measured by Voyager's instruments, a living boundary that breathes in response to space weather. As 3IATLAS crossed this boundary, its motion changed again, a softer drift, as though the object were adjusting to a new environment. Not mechanically, not intelligently, just responsively, like a leaf turning slightly as it moves from wind into still air. NASA's magnetometers detected faint fluctuations in the Fragment spin states upon entry, tiny shifts consistent with changes in the local magnetic field. Natural materials respond predictably. 3IATLAS responded subtly differently, not like rock, not like ice, more like something built to read the environment it passed through, built to listen. You sit in that softness, the idea that listening can be a purpose. What if the object wasn't trying to arrive anywhere? What if its destination was simply the journey itself? A drifting record of the galaxy built to slow whenever light grew stronger, built to adjust whenever magnetic fields changed, built to respond to everything it encountered. A structure made to witness. You breathe in slowly, almost reverently. Perhaps its journey ended, not because it reached a goal, but because it reached a star warm enough to illuminate its final chapter. A place where its last surviving fragments could scatter softly and release the faint stories they carried into telescopes, into data, into human curiosity. A quiet arrival not meant to be noticed by crowds, but by minds who listen softly. By people like you. You feel the warmth of that recognition settle through your chest. NASA scientists often say, the universe rarely brings visitors without reason. Not reason in the human sense, but reason in the cosmic sense. The way gravity shapes worlds, the way light shapes motion, the way time shapes existence. The presence of 3IATLAS in our sky might not have been aimed or guided, but it still mattered. Its arrival gave you a glimpse into a journey millions of years long. A glimpse into materials shaped by unknown environments. A glimpse into structures that carry purpose beyond language. A purpose that didn't need maps or missions or destinations. A purpose woven into form. A purpose made of silence. You feel a peaceful heaviness in your mind. Not fatigue, but fullness. Imagine a traveler drifting across galaxies, not searching for an end, but simply allowing the universe to carve its path. Imagine a journey where every star, every dust cloud, every magnetic tide is a destination in itself. 3IATLAS may not have been guided to us, but its path through space, its soft deceleration, its quiet adjustments, all of it feels like a story the universe wanted someone to hear. Someone patient, someone gentle, someone curious enough to listen without demanding answers. Someone like you let that realization breathe inside you warm and steady. And as the fragments of 3IATLAS float deeper into your awareness, a new question begins to rise from the quiet. A question not about where it was going, but about whether something else had once drifted beside it, sharing the same path, carrying a story of its own. You sit in the quiet for a long moment, allowing the idea of a traveler slowing near our sun to settle fully before your mind follows the next thread. A thread that feels softer, but also heavier, as if it carries a secret the universe gently hesitates to reveal. Because in the data surrounding 3IATLAS, there was something else, something almost invisible, something that didn't behave like debris or dust or background noise. A faint companion, Your breath steadies as the thought emerges, careful, calm, patient. NASA's early observations noted small anomalies in the brightness field surrounding 3IATLAS, not strong enough to classify as a secondary object, not stable enough to define, just a presence, a faint point of light that seemed to drift alongside the fragments, maintaining a curious proximity, not attached, but not separate, a follower, a twin, a splinter, a remnant of something larger. You feel your heartbeat quieten, not from tension, but from the tenderness of something unknown brushing against your awareness. Astronomers call such anomalies co-moving scatter. But this scatter behaved differently. It showed coherence, a soft alignment with 3IATLAS's trajectory that lasted far longer than statistical chance would normally allow. Coherence without structure is rare. Coherence without gravity is stranger. Coherence near an interstellar fragment is almost poetic. You allow that word to sit with you. NASA's photometric data captured small oscillations, dimming, brightening, dimming, like the flicker of something turning slowly, catching light, losing it, then catching it again. If it were dust, the flicker would be random. If it were debris, the flicker would be chaotic. But this was something subtler, a pattern faint yet persistent, as though the companion object held its own tiny rhythm, a rhythm that didn't match the fragments, yet still harmonized with them. Like two notes of the same chord, you feel warmth gather behind your chest. What if 3IATLAS wasn't alone? What if the object drifting beside it was once part of the same structure? Not a panel, not a curve, but something smaller, something with a different purpose, something like a sensor, something like a stabilizer, something like a watcher. You don't need to decide, you only need to imagine. NASA's preliminary orbital simulations showed that the companion's drift pattern resisted solar radiation slightly better than the primary fragments. Not dramatically, just enough to suggest a density difference. Heavier, tougher, built to endure longer. You sense the pieces rearranging themselves inside your thoughts, a larger curved structure, a scattering of light-thin fragments, and a heavier piece drifting near the core, as if the original object once contained a heart, not a living heart, a functional one, a center, a core component designed to survive longer than the rest. You breathe in the gentleness of that possibility. Objects built to last often have internal structures stronger than their outer shells. Voyager 1 carries internal hardware far sturdier than its golden exterior. Space telescopes contain inner frames designed to remain stable for decades, even if the outer casing erodes. If another civilization built something similar, maybe they shaped its center to endure long after its purpose faded. Maybe the faint companion was that center. NASA's spectrographic study of the anomaly revealed something unexpected. The reflected light carried a flatter spectrum, suggesting a material tougher and darker than the primary fragments. Not reflective, not delicate, not thin. Dense, a core traveling with its petals. You let that image bloom inside you, a still beating heart, drifting with the broken remnants of what it once belonged to. It doesn't need to function. It doesn't need to activate. Its existence is enough. A quiet center carrying the memory of purpose. You breathe slowly. Some scientists wondered quietly, cautiously, whether the companion might have been part of an anchoring mechanism. A structural piece designed to keep the main body oriented during its million-year drift. If so, then even in its fractured state, it remained loyal to the pieces around it, drifting beside them, mirroring their movement, staying as close as cosmic winds would allow. Loyalty is a human word, but the feeling fits. You imagine watching it from a few kilometers away, the fragments shimmering softly like scattered petals. And there, near the center, a darker, steadier shape that refuses to drift too far. A companion that does not leave. The night around you grows very still, as if it too is listening. NASA's magnetometer readings detected faint, irregular pulses coming from the companion, not signals, not transmissions, just subtle changes in reflected magnetic flux. Materials with internal tension can create such pulses. Metamaterials can as well. Artificial structures can too. But whatever caused the pulses, it was weak, old, fading. A technology outliving its maker by a million years often behaves like that, less like a machine, more like a memory. You let that thought settle with the softness of a sigh. Not everything built with intention survives forever. But some things survive long enough to reach someone willing to wonder about them, someone willing to listen. Maybe the companion wasn't meant to activate. Maybe its purpose was never to guide or communicate. Maybe it was meant to stay close, to remain as the final quiet anchor of a drifting structure. A structure that crossed the galaxy. A structure that slowed near our sun. A structure whose fragments scattered softly into our sky, while its companion kept following. The idea touches something deep inside you, something warm, something fragile, something human. Because everything in the universe drifts apart eventually. Stars drift from clusters, galaxies drift from neighbors, people drift from each other. Yet some things, some rare, stubborn things, stay close long after logic says they shouldn't. You breathe in that truth gently, and as your mind rests on the image of a tiny dark companion drifting faithfully beside fractured petals of light, another thought begins forming, quiet, warm, heavy with emotion. A thought about whether this companion was the last surviving piece of a message meant for whoever noticed it, or simply the final witness to a journey nearly infinite in age. The stillness around you feels almost sacred now, as if the night understands that you've reached the final curve in a journey that began long before your world existed. The faint companion drifting beside the petals of 3IATLAS still lingers in your thoughts, quiet and loyal, a fragment carrying the last breath of a forgotten structure. Yet even that isn't the end, because there is one last thing the universe offers you. Not an answer, not a revelation, but a feeling that begins as a soft pulse beneath your ribs, as though something vast has placed its hand gently over your heart. You stay with that pulse for a moment, letting it beat slowly, letting it guide your thoughts into the deepest part of the story. NASA's final analysis of 3IATLAS noted one more anomaly, a faint recurring pattern in the object's reflective signatures. Not a signal, not communication, nothing engineered in a human sense. More like a rhythm too faint for meaning, too soft for structure, too delicate for code, yet persistent enough to make scientists pause halfway through their measurements. The rhythm resembled thermal breathing, not literal breathing, not life, but a slow expansion and contraction of heat across the fragments, as though the object held a final fading cycle. Warmth rising, warmth falling, a heartbeat made of temperature instead of blood. You let that rhythm move through you, warm and slow. Objects that travel for millions of years accumulate such cycles. Thermal echoes of environments, they pass through star fields. They drifted across dust clouds that warmed them gently before releasing them into cold again. That cycle is a kind of message. A message without intention. A message without a sender. A message made of memory. You breathe into that softness. Perhaps that was the message all along. Not words, not warnings, not secrets, but endurance. The endurance of something built in the light of a star you will never know. The endurance of a structure carried across the galaxy, like a leaf drifting down an ancient river. The endurance of a purpose that no longer needs to be understood in order to matter. NASA once wrote, "Even silence contains information." You feel the truth of that now. The silence of 3IATLAS wasn't empty. It wasn't accidental. It wasn't a failure of communication. It was communication, a kind the universe uses often, in ways humanity is only beginning to appreciate. The silence carried the story of a traveler shaped by forces older than the sun, the story of a companion that refused to drift away, the story of materials that remembered their purpose long after they stopped functioning. You breathe out slowly, letting your shoulders fall. Somewhere inside you, a realization begins to form, gentle, patient, like a thought that waited for you to become quiet enough to hear it. The object didn't need to speak. It didn't need to declare its origin. It didn't need to explain its purpose, because its purpose was simply to last long enough for you to notice it. A message sent without a sender. A message received without decoding. A message written not in language, but in existence. You let that realization settle like soft snow across your awareness. Imagine a civilization knowing that stars outlive ideas, that galaxies erase borders, that time dissolves meaning, and building something that speaks not through complexity, but simplicity. Something that says, we were here, we wondered too. We shaped something gentle enough to survive the universe. You feel warmth gather in your eyes. Not sadness, not awe, something in between. A tenderness born from the idea that across impossible distances, curiosity might be universal. What if the creators of 3IATLAS never wanted to be found? What if all they ever wanted was to let the universe hold a piece of their existence long after they were gone? No message, no request, no expectation, just presence, a quiet presence drifting through the dark. NASA's long baseline radar detected one last detail before 3IATLAS slipped from view forever. A soft alignment between two fragments shifting slowly like two pieces of a memory turning toward each other. Not intention, just echo. But echo can feel like intention when the night is as calm as this. You breathe into that calm. If this drifting structure was created by someone else, someone who lived under another sun, someone whose world may no longer exist, then what you've been listening to is not technology. It's testimony, a testimony that asks for nothing, promises nothing, demands nothing, a testimony that simply is. You feel yourself soften, almost dissolve into the quiet around you. The universe didn't bring 3IATLAS to impress or frighten or enlighten. It brought it to remind you that existence is enough. Curiosity is enough. Endurance is enough. Silence is enough. And that somewhere across the incomprehensible width of the galaxy, there may have once been beings who looked at their sky the way you look at yours, with wonder, with fear, with longing, with a warmth that rises quietly beneath the ribs. Maybe they hoped their creation would drift far. Maybe they hoped it would outlive them. Maybe they hoped someone would one day notice its soft, persistent presence. Maybe they didn't hope anything at all. And you sitting here listening, breathing slowly in the dark, you became the final destination of that journey. Not Earth, not humanity, not science. You, because the object did not choose, but the universe did. The universe placed its story in your hands, in your thoughts, in the quiet of your night. Your breath deepens with that truth. And as the fragments of 3IATLAS fade gently from your awareness, leaving behind only a warm echo of everything they carried, you sense one last feeling rising in you. A feeling that doesn't need language, doesn't need certainty, doesn't need evidence. A feeling that simply whispers, you were never alone in your wondering.